Hi, I'm Ted East with Core Networks, and I'm at the Core User Group 2022. And I'm going to share with you what we just shared with everyone else here, our fantastic new offers with SAS. So let's get started. What I have with me today is a G Node B and a 5G device. What I can do is establish an IPsec tunnel from here at the EEC to AWS sitting in Frankfurt, Germany. Over in AWS, I'm going to deploy a 5G core. Now typically when we do this, our traffic would come from our 5G device and be routed across the IPsec VPN to AWS and then out to the internet. But we can do better. I've got a data center right down the street here, and what if we moved the UPF from the AWS location to the Helsinki data center, in essence separating the user plane and control plane. Then we then connect that data center back to the core that's running in AWS through a fabric. That allows us to keep the traffic local by using local breakout with an edge UPF. So let me show you how we do this. Okay. So when we were thinking about SAS, we came up with two key requirements. One, automate everything. The second one was to make it self-service. So picture yourself actually walking through these motions deploying a 5G core. So let's get started with deploying our first 5G core. First thing I'm going to do is create a new service, and then you'll have a catalog. I'm going to select the item that I'm interested in this case a 5G SA mobile core with local edge. Once I select this, it presents me with a quick topology of what we'll be deploying. I can see I have an edge cloud as well as the region cloud, and I have the option to select which software version I'm going to be deploying. We'll pick the latest. Next step is, where do I want to deploy this 5G core? So I have a menu of all the available region clouds that I can select. I'll go ahead and select Frankfurt. Once I do that, I have a little bit more fine-grained control. I can even pick which availability zone to deploy in. At this point, we select our traffic model, and so for today, it'll be just internet only. The next step is, what size of core do I want? Do I want a small, a medium, a large? It's very easy to select, and as I change this, it's really changing what's going to be deployed, the size of the infrastructure, the configuration of the CNFs. But for today, let's start with the small. The next step is, if we're going to do a lab, a pilot is fine. If this is going to be a commercial deployment, we would select standard, and I'd be able to select a second location, so I'd have geo-redundancy. But let's just go ahead and start simple. So we'll go back to a pilot. The next step is to define our edge location. So we're going to go ahead and select Helsinki. I certainly have the option to put multiple edge locations in if I desired, but we'll keep it simple once again, just with the Helsinki location. Now that brings us to configuring the core itself. We'll start by giving it a name. Once we have a core, we have to decide what is the domain name we're going to use. You have the option to bring your own URLs, or you can use one that's been pre-configured in our system. I'll select one that's been pre-configured. And then we start with the configuration of the core. The first step is the PLMNN, and I'm going to go ahead and just search for one, and we'll pick the demo network. The next step is the APN. So I'll go ahead and just enter what's been defined on the phone, which is internet. And then the tracking area. This is information you'll have from your G Node B. So I'm going to go ahead and enter one today. And that should complete the basic core configuration. We're not going to talk about charging, so I'm just going to put a placeholder in. We're already going to talk about the test subscribers. It'd be very useful that once we deploy this core that we could immediately use it. So I like to seed the core with a handful of test users. So let's do that. We'll start by defining the MZ for first user 1, the MSISDN, and I'll go ahead and put a K value in as well. And we'll add that subscriber. Now, if you're like me, when I burn SIM cards, I usually start with 1 and then 2 and then 3, and we have a great little feature here that allows you to duplicate these subscribers. So I'm going to create a handful of subscribers. The next step is the advanced options, and this is really based on feedback that we've heard back from you. The first one is the secondary CIDR. It seems like no matter what IP address I pick, inevitably it's always one that's in use. So what we can do here is you can just specify an IP address or IP block that's not in use, and then we won't have a conflict. The next feature allows you to bring your own IP to this deployment, and this will be used in the UE pool and will be the IPs that are assigned to the actual devices. So in this case, I have an ASN, which is an autonomous system number. I'm going to go ahead and enter mine, which is 7345, and then an IP block that I wish to bring. So I'm going to do 135.109.194.0 on a /24. The next step is metrics. So this is going to show up in for our operations. And that finally takes us to connectivity. So how are we going to connect to this core? If this was commercial or a commercial deployment, we would use direct connect with a fabric provider. But since we're just doing a pilot, we're going to use an IPsec VPN, and that's what we showed on the slides. You can go ahead and create a new VPN tunnel endpoint, and this would be the tunnel endpoint on your network. But I have one that's already been defined, so I'm going to select one that's existing. The next step then is to define the pre-shared key. So I'm going to go ahead and enter that one. Oh, let me try that one more time. There we go. Followed by the CIDR where your G node Bs are located. And this is to tell us how to route back to your radios. So let me go ahead and enter that information as well. So now we got the basics of the VPN configured. We just need to configure it with what I call the VPN 101. If you've done VPN or IPsec tunnels before, this is relatively common. The key here is you're defining the security requirements, not us. Whatever we put in here will be provisioned on the far side. So I'm going to go ahead and select AES 128. We'll do a SHA-1 with a Diffie-Hellman 2. And then we'll repeat this for our Phase 2 proposal. Once again, we're going to do an AES 128 with a SHA-1 and a Diffie-Hellman 2. We'll go ahead and review. And we can see what are we going to deploy. We have our core, and we've named it CUG. When are we going to deploy it immediately? We do have a scheduling function as well, so you can deploy these cores automatically. Where are we going to deploy it? We're going to put it in Frankfurt. This one has an edge location that we'll be doing in Helsinki. It's internet only. We've got our core configuration as well. Some test subscribers loaded, and it's going to be connected through a VPN. So let's deploy this core. Now what's happening behind the scenes is the SaaS software is reaching out into the AWS account, and it's creating the AWS environment, starting with the VPC and then moving on to the EKS cluster. Let's go ahead and switch to a core that I already have deployed. So I'm going to select one that was deployed a couple hours ago, and we can see that this one's been successfully completed and deployed the various CNFs. So here I've got my AMF, my UPF, my SMF, my MRF, and then I've got the rest of the mobile core as well, the UDM and the SDL, and we threw a NEF in there so you have API exposure as well. Now you have the core deployed, you need to know how to connect to it. So the system comes back and it tells you we've set up redundant VPN tunnels. So you have tunnel 1 and tunnel 2, and you'll enter these tunnel endpoints into your IPsec appliance, and that'll set up the connectivity between the G node B and the core running in AWS. Once we have that done, we're going to then move on to the AMF. So how do we actually point the radios to the AMF? Now that we have our VPN configured, the next step is to point the G node B to the AMF that's deployed in AWS. So if we look, we can see the IP address of the AMF, and let's just look at the last two octets, 8066. So I'm going to go ahead and switch over to the G node B, and if I click on it, we can see that I've already got it provisioned to the AMF. And the G node B is currently on air, as we can see at the top. So I'm going to switch now to my phone, and we'll run a quick speed test. All right, the key thing to notice here on the speed test isn't necessarily the speed of the download or the upload, but it's the latency. We currently are at 14 milliseconds latency. Now I asked the tech crew here at the EEC what their air interface latency was, and they said it was at 12 milliseconds. So that means it's only 2 milliseconds once we pass the air interface to get to the UPF. And remind you, we are going through an IPsec tunnel, which is clearly adding at least a millisecond there. So I want to show you one more thing. I'm going to switch over to Google Chrome, and I'm going to look up what is my IP address. And here you can see my IP is the 135, the 109, the 194.1. This is the IP block that we use for Bring Your Own IP that we're currently advertising out of the UPF by a BGP. The significance of this is when you deploy a core on the hyperscalers, even with local edge, you want that core to appear that it's coming from your network. And that's exactly what this is doing. Okay, so let's summarize what we just did. From the EEC, where I'm currently at, we set up an IPsec tunnel to AWS where we deployed an entire 5G core. We put the UPF literally right down the street on the edge that allowed us to do local breakout. The results of that was we had ping times of 14 milliseconds, and we know 12 milliseconds was just attributed to the air interface. All of this deployment took approximately about 2.5 hours. And remember, our starting point is there was absolutely nothing pre-provisioned. So thank you for your attention.